telescope recorded the traces of the four oldest galaxies. They were formed 350 million years after the Big Bang. In December 2022, scientists announced the discovery of the farthest, and thus the oldest, galaxy whose light has been recorded. In a new paper published in Nature, the same researchers are already talking about four galaxies, 13.4 billion light-years away. Astronomers are now confident that light from the four galaxies studied has been traveling to Earth for more than 13.4 billion years. These galaxies existed when the universe was less than 350 million years old, according to a study just published. The data shows that the first generation of galaxies appeared very quickly after the Big Bang, the beginning of everything. It was crucial to prove that these galaxies really came from the early universe, says Emma Curtis-Lake, an astronomer at the University of Hertfordshire in England. She is a co-author of one of the new studies just published. By observing the spectrum, we were able to confirm that these galaxies are at the true edge of our field of view. Some of them are much further than the Hubble Space Telescope could look. This is an extremely exciting achievement, adds Curtis-Lake. The oldest galaxy was found last year. For the first time, we discovered a galaxy that existed only 325 million years after the Big Bang. We can be absolutely sure that the light comes from these fantastic distances, said astronomer Brant Robertson of the University of California, Santa Cruz at the time. Seeing such unusually early formations in stunningly beautiful images from the James Webb Space Telescope, JWST, is a unique experience. At that time, the galaxy was primarily called Jade's GSZ 13-0. The latest data already shows four galaxies, named Jade's GSZ 10-0, Jade's GSZ 11-0, Jade's GSZ 12-0 and Jade's GSZ 13-0. They all show the so-called extreme redshifts, from 10.3 to 13.2. It is worth noting that the name JADE stands for JWST Advanced Deep Extragalactic Survey. How the Webb telescope explores the early universe. The discovery confirms JWST's ability to study the early universe. It was made possible by the detection of light that had traveled so long that the expansion of the universe stretched its wavelength. This stretching of light is called redshift. The longer light travels, the farther towards the red end of the electromagnetic spectrum the expansion of the universe will push it. This means that redshift can be used as a measure of distance. Early galaxies should have light showing extreme redshifts, right into the infrared range. And that's exactly what Webb's specialty is. Such observations are made possible by JWST's near-infrared cameras, NIR-CAM, and the Near-Infrared Spectrograph, NIR-SPEC, instrument. To date, the $10 billion observatory has identified several galaxies with extremely high redshifts. These observations have yet to be confirmed with spectroscopy. The oldest galaxies do not contain heavier elements. Spectroscopy can be used to distinguish between early galaxies, and thus more distant ones, from closer, more recent galaxies that may exhibit similar properties. Spectroscopy helps to make this distinction because it can detect the characteristic signatures of certain elements. Early galaxies are mostly hydrogen and helium. They are devoid of heavier elements such as oxygen, nitrogen, and carbon. These formed in the cores of large stars as a result of mergers. They were dispersed throughout the cosmos by supernova explosions. This is why early galaxies are devoid of heavier elements. The researchers pointed out that the spectra of the galaxies studied do not have the characteristic signature of heavy elements such as carbon. This means JWST sees them as they were when the universe was only 300 to 500 million years old. Let us add that the age of the universe is estimated at about 13.8 billion years. Thousands of galaxies from the distant past. The observations come from the first series of JADES detections, from an area of sky known as the ultra-deep field. It was previously studied by the Hubble Space Telescope. This patch of sky contains about 100,000 stars, galaxies, each captured at some point in their history, potentially billions of years ago. Scientists used more than 10 days of the JWST mission to study the ultra-deep field with NIR-CAM, observing it in 9 different infrared bands. The NIR SPEC instrument then collected data for 28 hours over 3 days. JWST therefore provided exceptionally sensitive and sharp images of this area. It also collected the data needed to precisely measure the redshift of each galaxy and reveal the properties of the gas and stars in each galaxy.